In this problem, we have two reactants that are given some of the information, and there's a reaction between these two. So let's first write down the reaction between these two reactants. So we have aluminum solid plus copper 2 sulfate solution. And from this equation, we can tell that it is a single replacement reaction. So the aluminum and copper will be replaced. So we have copper solid plus aluminum sulfate. Okay, it's a solution. So we are going to balance this equation because we have to make use of this balance equation to find out the number of moles. So we have 2 aluminum. We have, oops, we should have 3 here. So we have 3 copper 2 sulfate, and then we have 3 copper here, and now we are balanced. And now, let's look at the given information. So we are given the volume and the molarity of the copper 2 sulfate, and we are given the amount of grams of the aluminum. So we are given the information of both reactants. And remember that when we have a reaction and we have 2 reactants, it is very likely that one of the reactants will be used up first, and that's called the limiting reactant. So we have to find out which one's the limiting reactant. So first, let's find out how many moles we have for each reactant. So if I want to find out the moles of copper 2 sulfate, so we have molarity is equal to mole over volume, and mole is equal to M times V. And it is a very simple calculation because we have 1.5 molar times 2 liter. And that gives us a very nice number, 3 moles of the copper 2 sulfate. And let's find out the moles of aluminum. So we are given the mass, and we are going to use the molar mass of aluminum to find out what is the number of moles of the aluminum. So we have 1 mole of aluminum is 26.98 grams of aluminum. And if we use a calculator, we will find out that it is 1.483 moles of aluminum. Okay? So let me write these numbers right here so you can see it better. So we have 3 moles of this and 1.483 moles of the aluminum. Just want to clarify that this 3 has nothing to do with this 3. They are just coincidentally that they have the same number. Okay? And now we have to find out the limiting reactant. So let me just erase this part so I have more room to work on the math. So since we have 2 numbers, we pick either one, and I'm going to pick this one. This is an easy number that I don't have to use my calculator to find out the limiting reactant. So we want to find out the number of moles of copper 2 sulfate needed. Okay? So we start off with 3 moles of, oh, sorry, it should be aluminum required, needed. So we start off with 3 moles of copper 2 sulfate. And then we multiply by the mole ratio. So we have 3 moles of copper 2 sulfate from here, from the coefficient, not from the given amount. And then we have 2 moles of aluminum. So this is very simple. So we would need 2 moles of aluminum to carry out the reaction to completion, to use up all these. This is the amount we need, but this is the amount we have. So we can tell that the aluminum is the limiting reactant. So we're going to use the number from the aluminum to calculate the mass of copper will be replaced. So let me erase this part. Okay, now let's do it in 2 steps. So we know what is the limiting reactant, and now we can calculate the moles of copper replaced. Okay, and to calculate this, we are going to use 1.483 moles of aluminum, since this is the limiting reactant, and we're going to use mole ratio between the aluminum and copper. So we have 2 moles of aluminum to 3 moles of copper. Okay, and we have, if we use a calculator, we will find out that this is equal to 2.22 moles of copper. This is the number of moles of copper replaced. And then we can make use of this mole to find out what is the mass of copper replaced. So start off with 2.22 mole of copper, and then we would use the molar mass of the copper, which is 1 mole of 1 mole of copper is equal to 60, I believe is 63 point something, 63.55 grams of copper. So mole cancel out, copper cancel out. So we would get 141 grams of copper. So from this reaction, this is the amount, the mass of copper that we expect to get if it is if this reaction has 100% yield.